Welcome, everybody, and thank you for joining this afternoon, this morning, depending on where you are. We're here to talk about machine learning, how to make it real, how to make it profitable. So a very interesting topic, certainly for myself. And with us today is Lynda Partner. Lynda is an SVP of Analytics at Pythian, a global IT services company who helps organizations leverage data analytics and the cloud. And with that, I will hand it over to Lynda to start our presentation.
Great, thank you very much. Make sure the screen sharing is working. Trust somebody will say something if it's not.
We got you.
All righty, thanks everybody. So yes, I do work for Pythian. It's a 400-person IT services company, and all we do is data analytics and cloud. So really, bunch of really smart people who apply their knowledge to help companies all over the world. One of the things, though, that I've discovered as I work with clients is that when it comes to machine learning, or any data project for that matter, the biggest challenge that organizations have isn't diving in and using the technology. It's more about figuring out how to justify it, how to demonstrate that this is actually going to produce good outcomes, and equally important, a good ROI. And machine learning, I think, just takes that challenge and amplifies it. It's the latest, shiniest buzzword in analytics. Everybody's talking about it. It's a technology with huge potential. It has the potential to change your business for good, but it also has the potential to waste a lot of time and a lot of money. And the last thing anybody wants is to engage in a project that fails spectacularly, because that will taint your ability to do the next one and the next one. So we spend a lot of time trying to figure out how we can help organizations go through their machine learning journey and do it so that they can produce good outcomes at the end of the day that have good ROI. So my goal today is to give you some pointers that will help you tip the scale towards using machine learning in a profitable way. So while the topic of this talk is actually about machine learning, my first tip is this, and that there is a danger in being too specific, especially if you're dealing with literal people. Data scientists are literal people. So machine learning is really part of a broader category of advanced analytics technologies. So by keeping an open mind, you might discover that the solution to your business problem might lie in advanced analytics, but not necessarily ML. So for the rest of the talk, I am going to use ML, or machine learning, as a proxy for the larger category of advanced analytics. So the promise of ML is unbelievably compelling, to think that machines can produce insights that humans could never derive from data, that they can make better predictions than could be made by humans alone, that they can do real-time automation at scale and deliver better decisions, efficiency, and speed, and create more time for the creative aspects of our job while they crunch away and do all the detailed part of the data crunching, and new opportunities that might come as a result of this. So the promise is there. And if you listen to the media and to a lot of vendors, machine learning is actually in widespread use, and it's delivering these results left, right, and center. And so you might be forgiven for thinking that you're the only one not using it through your organization. Sorry about that. But the reality of how widespread the use is a little bit different. And it doesn't take long to do an internet search and figure out how real is ML, how successful is ML. And all of these tidbits of statistics and data have been published in the last 6 months. And you don't have to look far to see people like Gartner saying over 85% of data science projects fail. And only 4% of companies have succeeded in actually deploying their models to a production environment. And 47% fail to take their initiatives out of the experimental phase. So it really sounds like where we are right now is a fair amount of experimentation and not a lot of ROI happening yet. And I'm showing you this not to discourage you, but to point out that understanding what's behind these statistics is going to enable you to take the steps now to change these outcomes so that you're not going to be experiencing these outcomes. Because unless you're really unusual, if you do what most people do, you're probably going to experiment these same challenges. But the good news is that there is a way that you can change some of this. It is not inevitable. It matters it matters for a couple of reasons. That all of those stats that I just showed you translate into math. You take all of that and distill it down, and it basically says that for every 8 projects that are started, 4 make it to the deployment phase, and only 1 gets deployed into production. And those are particularly good odds. If you say I'm going to start with 8 and only 1 gets deployed into production, you have to take into account the cost of all the work that you did on all of the 8 to demonstrate your ROI on the 1. And if you use published survey data about the effort and the duration for each of these phases, that can translate into $1 million to $2 million per successfully deployed model. Now, I actually used published data to come up with this average cost of a model. Obviously, results may differ. And it's not unreasonable, though, as we have some customers whose average model costs are, in fact, much higher than this. So if you're trying to get a return on an average model cost of $1 million or more, it's a lot harder than getting a return on a lower successful model cost. So what we're going to talk about today is how to change this math, how to get more models through to a successful deployment so that the average cost per successful deployment goes down, and therefore your ROI math is a lot easier and more powerful. So the way that we're going to do this is break down the steps in an ML project and give you some suggestions on how to make each step produce better, faster results. Now, we all know that when it comes to any transformation project, you require people and process and technology. But today, we're really going to focus more on the people and the process side of things. So at a really high level, the machine learning journey looks like this. You pick a use case, you build and train your model, you deploy your model, and then you manage your model ecosystem. You can't skip any of these slides, and you have to do all of them. And the last step goes on for pretty much forever. So machine learning isn't a project that starts and stops. It has to become part of your ongoing digital system. But because this is only a 30-minute talk, we're going to spend most of our time on picking the use case. Because if you think about those 8 that start and only 1 gets completed, if you can pick the right ones sooner and fewer of the right ones and put them through, then you're going to end up with a more successful program. I'm going to start at the beginning. I'm going to go out on a limb, and I'm going to say that modeling for the sake of modeling isn't the way to success. Yeah, I think everyone's going to agree with that. Just like technology for the sake of technology might be fun for some people, but it has to be connected to the business to be the right decision. So picking a use case should start with the business. And luckily, most of us know that, and it usually does. But as I'm sure you've all seen, the first problem that we run into when it comes to machine learning in particular is a communication gap between the business and the data scientists. They both want the same thing. They both want this to be successful, but the communication gap can sometimes get in the way of even a common understanding about what the use case should be. So here's a quick example. This is actually a true email from one of our prospects. He sent this to me and he sent the answer. The business person might write to the data scientist and say, hey, Joe, can ML help me identify which customers are most likely to cancel their subscription this year? It's a beautiful use case, right? Perfect way to start the conversation. And the answer came back from the data scientist, sure, please be the following. These guys are so keen. They love their models. This is literally the answer. The design and testing of supervised machine learning models combine 2 fundamental distributions, the training data distribution, the testing data distribution. And although these 2 distributions are identical and identifiable when the data set is infinite, they are imperfectly known and possibly distinct when the data is finite and possibly corrupted. Anyway, I don't have to read it all for you to get the gist of what I'm saying. So this is the single most important thing that you can do at the beginning of your process. The best way to select the best use case is to bridge this gap, to involve the data scientists and the business people and IT, don't forget IT, in the process of identifying and selecting the use cases that are most likely to succeed. And remember that success is that they make it through to producing a return on investment as quickly as possible. And an easy way to do this is to consider using a framework like the one that I'm about to show you that brings together all of these people and has them develop a common framework for identifying the right use cases and then picking among the best use cases. So the first and most important thing is to get all of these people together. You can't do it, have one set of people do it and throw it over the wall and expect someone to pick it up. It's really important that they all come together and collaborate and answer a common set of questions that are focused on business problems and business impact. When we do this, what we always find is that people have lots of ideas about how they think they could improve the business and how they think ML might be able to help them. So this simply frames the discussion in a consistent way across all of the ideas. And it usually starts with the business people. And we ask the business people to fill in the rest of the statement. The statement goes like, I would like to accomplish something. Describe what it is you want to get out of this. So we could, what is the thing that you can't do today that you think will improve the business? Which could result in, and this is where you start identifying what the business outcome is likely to be. And then the teams all come together and say, oh, that's interesting. If you wanted to do this, it would require, and then it might be some systems changes, it might be some data, this is where the conversation starts happening with the data scientists, and the team together determines what's required to be able to accomplish that business goal. And then once they've done that, then together they look at, well, what would be the business impact if we did this? Is it a little bit of savings of money? Is it a huge new revenue stream? Is it reduced churn? What's the business impact going to be? Is it a high business impact, a medium business impact, a low business impact? And then lastly, and now the data scientists get to chime in, they now have a good context and a framework for the problem that they're trying to solve. And then they can chime in with whether or not this is likely to be a good machine learning candidate. And a surprising number of these things turn out not to be good candidates, but some of them are going to be. And so when you do this, and this is a filled in example. So for example, here's one of the first one. I would like to predict which customers are likely to leave us so we can keep them engaged. And if we could keep them engaged, we feel that this could result in 7% less churn, which means $7 million in retained annual revenue. And to do that, it's going to require us to have descriptions of customers that have left and why they left or how they were enticed to stay. And if we could do that for this particular business, they determined that this was a high impact on the business. And then the data scientists could say, you know what? If you could get those descriptions of the customers, then I think that it is a good candidate for machine learning. And in fact, I would use hybrid sequence model to do it. And so when all of the teams come together and they create this in collaboration, then what you end up with a list of ideas that are ranked by business impact, that identify what the outcome is going to be, and that are aligned with whether or not this is a good machine learning candidate. So it makes starting with the business more pragmatic. Everyone says start with the business, but rarely do they say how to do it. This is the way to actually do it. It forces you to define business success up front, and that's going to end up helping you pick the best use case. It pushes the decision on whether to use ML to solve this problem to later in the discussion. And you'd be surprised at how often ML isn't the answer. Sometimes a much simpler solution is available. It helps the data scientists understand the business part of their work, and this is going to help them when they're faced with different choices as they develop the model. It's going to avoid that, wow, look what we discovered that has nothing to do with the problem the business wants to solve problem. And the power of ML is that it is so open to inputs and outputs that the danger with it is that you have to focus the outputs on solving the business problem. Otherwise, the rest is just playing. And playing's fun, but it doesn't get you to an ROI. So going through this exercise isn't always easy. It takes a while and it takes patience, but at the end of the day, it's going to set you up for the next stage in the process of selecting the best model. So now what you've done is you've got a whole bunch of candidates in that last exercise that all came out as being good candidates for ML and having a high business impact. How do you pick among them? Now what you have to do, because we want to also have faster time to value, you have to now add two other elements to your formula. The first is you have to take the high business impact and combine it with those that have the lowest data risk and the highest technical feasibility to get you to the faster time to value. And so the equation is simple: high business impact, low data risk, high technical feasibility means that you are likely to get something coming out the bottom faster and for less money. So let's talk about data to start with. Here's my favorite slide. It is the Cookie Monster. And I have an analogy that says that your ML model is a lot like the Cookie Monster. He's a voracious consumer of cookies, and the more cookies he gets, the happier he is. Your ML model is also is like the Cookie Monster in that it is a voracious consumer of data. And just as your Cookie Monster wonders how easy it is to get access to cookies, your data scientist is wondering how easy it is to get access to the data it needs. And remember that more time to get access to data means not just a slower path to success, but also higher costs. And just as your Cookie Monster needs lots of cookies to satisfy his hunger, your model needs lots of data. The more data, the better the output, and a continuous stream of new data is even better. And just as your Cookie Monster isn't keen on burnt cookies, your model depends on clean data. And as it turns out, that the average baker in our scenario isn't very good at avoiding burnt cookies. The good news is that while we can clean the data, we all know how time-consuming that can be. And having expensive data scientists spend up to 80% of their time cleaning data instead of modeling adds both time and cost to your ROI equation. And lastly, strangely enough, your Cookie Monster doesn't like vegetables. So consistency in what we feed him is good. And likewise, your model would rather avoid data inputs that change their schema by the minute. So accessible, clean, integrated data is one of the most important ingredients to being able to implement not just successful models, but also more rapid deployment of ML projects. Sadly, the reality is that most data estates look like this. Siloed data is the norm. Siloed data by definition isn't consistent. Siloed data isn't very accessible, not integrated or easy to use. And when it's siloed, nobody really knows how clean it is. So you end up with the manual processes of extracting and cleaning and integrating data so that model development can start. It's inefficient in the extreme, and the cost of this alone can kill your project. Forget all the other things I've said so far. If you can't feed your Cookie Monster model with clean integrated data at scale, then it's going to be really difficult to get an ROI. And creating this modern enterprise data platform of organized data isn't just a value for your machine learning model, it's also a foundation for self-service analytics across the business for creating insights. So we don't want to be too narrow and just think about ML. We want to think about analytics on a broader scale. It's a way to orchestrate the outputs of your analytics and deliver them to other systems. And it could be a new source of data that can be used for application development. So it is important in many, many fronts. And lastly, the garbage in, garbage out axiom holds very true in machine learning. You can have the best model in the world, but if the data you feed it isn't good, the result isn't going to be either. And I would venture to say that you can have the best data in the world, but if your model is garbage, then you also won't get good results. So all of these things have to be in balance. You have to have clean data, you have to have a clean model so that you can get good results. And finding good modelers is also a challenge for most organizations. The best data scientists can model, but they're also able to talk to the business and connect the dots between what they do and business success. That's asking a lot, but for today, we're going to assume that you have awesome data scientists. We're not going to focus on that part of it. So how do you take all of that and then do something practical with it that's going to help you determine which use cases are the best? Well, you can create something like this, where your data risk score has attributes. You can look at the quantity of the data that's available. Remember, your Cookie Monster wants a lot of it. You can look at the accessibility of the data, how easy it is to get to. You can look at the stability of the data. Dealing with unstable data is higher risk than dealing with stable data. And of course, you can look at the quality of data. And then you can do an assessment of your data and put values on this continuum and end up coming up with a data risk score. And you also have your technical risk score. While the data is a huge component of this equation, technical risk has to be taken into account. And the attributes that you can look at here are the model complexity. If you remember back on that framework chart, we had, they were all high candidates for ML, but there were different models being selected for each one. And some models are harder to do than others, and harder means more time, harder means more cost. You can look at the time to develop. Some models you can pull off the shelf and go very quickly with because people have done them before and made them available. Some of them have tools that are more readily accessible. You can also look at your ML ops capability. It's your ability to deploy the model once you've actually built it. It's one thing to say, for example, a model is going to give a prediction to a person on a screen. It's a completely different thing to say that that model, that those predictions are going to be embedded in the next Netflix application and continue to change by the minute as people use the application and the data changes. So your ability to actually do something with the output of the model is an important element of the technical risk score. And then lastly, the consumption complexity. Like, how are you actually going to make that data available? How are you going to consume it? Is it simple and straightforward in a dashboard? Or is it something that has to be integrated into another system and with dependencies? So this is where your IT folks get more involved because they can work with the data scientists to understand what the technical risk score is going to be. And then what happens is that you can then plot it. So this is what you end up with. Let's say you have three use cases that all have high impact on the business, and then you're trying to decide which one to go with. And you've gone through the exercise of assessing the technical feasibility and the data risk. And then if you plot them on a continuum like this, then it shows you that use case number one in this scenario has very high technical feasibility and very low data risk compared to number three, which is going to be tricky from a technical feasibility standpoint and has high data risk. So if you have to pick among the three that all have a high impact on the business, which one you should start with, which one is the one that is most likely to deliver better results faster and therefore a better ROI, it's likely to be number one. And doing all of this and just working through this exercise will help you pick the most likely successful plan. And it also gives you a backlog of the next ones to work on once you've got the first one implemented and everybody is enjoying the benefits. So that's a typical exercise that you can go through. We help organizations go through it all the time, and it sets the stage for future success. Now, I'm going to have to skip quickly through the rest of these, which are complete sessions on their own, but I just want to touch on them to make sure that we're clear that I'm not advocating that it stops there. You know, there are other steps in the process that can be accelerated or can introduce barriers. And at the building and training a model, there are some keys to faster success. And you'll see that there's starting to be a theme here. Access to lots of clean data. Here we go again. Strong communication with the business, connecting the dots back to business goals. We've talked about those in selecting the use case. They continue throughout the whole process. You also need these knowledgeable experience modelers. Without them, it's going to be really difficult. And integrated development in environments are going to make those modelers and the subsequent deployment of the model much faster and easier. At the deploy the model stage, the end-to-end pipelines for machine learning is more complex than regular data pipelines. You know, they're usually done very manually. It means time, it means money, it means mistakes. Deploying and developing and deploying on a single system that's capable of automating the end-to-end process at scale is going to be key at this point in the process. But this is a whole other area. It's one that IT is especially involved in. So we can set this one aside in the interest of wrapping up right now. Our focus has been more on picking the right use case. So wrapping it up, for companies who are in the early stages of ML maturity, these are the 4 pieces of advice. One is spend more time on use case selection. I can't overstate this enough. And to do that, it's a team sport. You need IT, you need data science, you need the business. Invest in a cloud data platform. This is the thing that is going to organize your data for you and speed up everything once you've selected your use case. You need IT for this. You know, the business can't do this. The data people alone can't do this. You're going to want to start a data governance program. You're going to want to make sure that your use of data is consistent across all of the use cases. And for that, you need IT and business. And you need to educate more people about machine learning. And this is all in the interest of reducing the communications gap. Understanding good use cases and bad use cases, understanding what machine learning means and how it's going to change the business means a lot of talking. That's how you get started. And if you've already done the above and you want to take the next step, the 3 best pieces of advice I have for you are to invest in an integrated development environment. You need IT for that, but it is going to take you from a really long time to get through this process to a much shorter time. And it's going to eliminate a whole bunch of costly mistakes in the process. You need to invest in ML ops skills and tools and processes. We've seen so many of these just get stalled at the point where they have their model, they just don't know what to do with the output. So the ability to actually take that model and deploy it in production and run it at scale and have it operate without you having to worry about it is super important. And you don't want to get to that point and then have everything grind to a halt. You need IT for that. And then start thinking about model management. Models don't just set them and walk away. You need to ensure that these things continue to be tuned and optimized and tweaked and tuned. And for that, you're going to need your data science people. So no one group in a company can ever say that they can improve the ROI and make these a success. It has to be a collaboration of all of these people. If that sounds like a lot of moving parts and a lot of people, it is. But this has been going on long enough that there are known best practices. There are methods and processes for moving forward, and help is available from people like Pythian and from others. So anytime that any of you want to reach out, just pick my brain about what we're seeing and what works and what doesn't work. We're all in this journey together. And every conversation that anybody has adds just a little bit of knowledge to the community learning. And everyone at Pythian, including myself, is happy to share. I can be reached at partner@pythian.com. and nobody told me what to do when we were done. So I am going to stop sharing.
Thank you, Lynda. I'm just looking at the chat here. We're opening up to questions now. We've got a few minutes. I see one from Ravesh. At what point does one decide to cut cost and not proceed in machine learning driven solution journeys?
The first point, the first decision point has to be, if you can't find use cases that have that good formula of high impact on the business, low data scores, and or high data scores and low feasibility, you got to start wondering before you even really get started. And then at each step along the way, there's different measures. You can set up different measures of success that say, if I'm at least here by this point in the process, then it's worth continuing. But the reality is that at the end of the day, getting your data ducks in order and picking the right use case are the two most important contributors to a go, no go decision. So focus on those two.
Okay. You mentioned in one of your last slides the importance of data governance. So for companies that have, let's just call it a traditional data governance, based on some of the more legacy embedded technologies in a company, how do they evolve that, or do they evolve that to incorporate artificial intelligence, machine learning, more modern ways of thinking about data science and how to govern that type of data?
Yeah, it's a big conversation. I'm going to oversimplify my answer and say, traditional companies with highly governed data in data warehouses can get results from machine learning, but without making a change to a more modern data stack, the results aren't going to be as good. So for example, in the modern data world, where you have a lake and a data warehouse, not just a data warehouse, you have two pools. You have your highly governed data in the data warehouse, which is used for financial reporting and dashboards. But you can create this other, either ungoverned or lightly governed data set in your lake. And that's where the data scientists really like to play. So it's moving into this new world where everything isn't as black and white and everything isn't as governed, but putting enough light controls over things that you don't have, runaway data projects, that you're going to get your best results for machine learning.
Okay. Another question just came in here in the chat for companies that are seeking innovation within ML AI. How important is it to bring cross-functional departments out of data silos?
That's the thing. It's everything. I have literally seen projects where the data scientists have been doing things in a silo and they come out and they go, ta-da! And then the business person looks at the output and goes, well, yeah, or that is the dumbest thing I've ever seen for these 5 reasons. So the problem in operating in silos is everybody thinks they're doing the right thing. It's just they don't have the context for understanding the bigger picture. And bringing people together, at least at the beginning of the journey, and establishing what success means gives everybody, even if they go back to their data silos later, that at least understand why we were trying to do what we were trying to do. And it will be a way to guide their actions, even if they're not coming together as often as they should. It's just like, where you want to go, what your destination is. Like sometimes you're going to end up taking a back road instead of a highway. But if you always know you're all trying to get to the same place, then, you might actually end up there.
Mm-hmm. That's a great point. Um, Another question coming in from Indra. Are you aware of the use of machine learning in the M&A market?
Yeah. We have one project where we're working with a private equity firm, And they are using machine learning to uh, benchmark and evaluate and predict which opportunities to acquire are likely to produce the best outcome. And I think, I can't say a lot more than that, but what they did is they went through a very similar exercise, and their big challenge was, is ML a good candidate for that? And they spent a lot of time figuring out, is it a good candidate? And they came up with 5 different use cases, and only one of them was a good candidate. So like in most businesses, sometimes you can find tons of use cases that are really good. In others, it's a lot trickier. And so far, the limited experience we have in this market says a lot of the stuff that they want to do, it was just as easily solved with other analytic forms, and only one of them came up with a good use case for ML.
And I'm actually curious, in your experience consulting with companies across industries, is there a model exemplary industry where they are really doing a good job of taking these lessons and best practices to heart, getting all of the fundamental pieces right from the get-go?
I don't know that there's an easy answer to that, but I can say that there are some repeated use cases that we see over and over again that are obviously delivering good ROI, or they wouldn't keep doing them. And especially in COVID times, it's around supply chain optimization. And so anything that has to do with reducing costs in an organization right now has got high attention. Predicting failures in expensive equipment is a really good example of that. And there's there's a lot of activity around that. Teck, the mining company, has these huge trucks, and we were able to help them identify when these trucks were going to break down, so that they didn't, travel out into the middle of nowhere and break down without any way to repair them. Another really important area is in the area of customer journeys, and looking at it selfishly, how do you enhance the customer journey so people want to buy more? So predicting and avoiding churn, next best purchases. So anything that has to do with making the digital experience so personal and so good that people want to buy more and do it quickly and easily is the other big area. So one is all about revenue growth and customer retention, especially in digital. And then the other one is about cost savings. And those are the two that we're seeing the most interest in these days.
Okay. I think we have time for one more here. So DARPA and NSF have committed to increase AI grant funding. Given the proposed push for infrastructure investment in the US, do you foresee other agencies increasing funding?
I am not an expert in US government policies, but
Okay.
I think it is safe to say that most countries have recognized that AI and ML are going to play a really important role in global competitiveness, and that if there is one area of investment to remain competitive, I suspect it's going to be not just ML, but by its extension into AI.
I have a question. I said one more, and now I've got 2 more questions here in chat. So these are great. From Tanya, what should the data team size be for companies who received models through consultation?
Oh, sorry, could you repeat that? What should the data team size be?
For companies who received models through consultation. So maybe as you're going in and helping a company to build out some of these modeling capabilities, what is the team size that they need to think about building to maintain that over time?
It would depend on a bunch of factors, right? Like how much data you have, how stable your data is, how many models you have running, how mature your infrastructure is and your ML ops capability. You know, we see immature organizations having to have large teams. You know, we're working with a financial services company right now who has a team of 50 people just managing the models that we're helping them deploy. And then, but what's interesting is that over time, with this new world of ML ops, everything can be so automated that the ongoing care and feeding of the system is now less about deploying the pipelines and just more about making sure the models don't degrade over time. So technically, if you do this right, your team should decrease over time if you embrace automation fully. That's the promise. I can't tell you how many people you need, but I can tell you can probably reduce the number of people over time.
Okay. With that, just many statements of gratitude and thanks in the chat. So I just wanted to reiterate, thanks for a super presentation, very informative. And I think people know where to find you. I'm not sure, given the time of day, if you're planning to be in the networking breakout room virtually for a little bit, but I'm sure if you are, people can meet you over there.
I am happy to be there.
And thanks again.